Hey.
Hi.
Don't give me one.
Yeah,
Why not?
Hi, how are you? You're on mute. Which is okay, I guess, if you don't want to talk to me.
Hey,
Hey.
I'm just setting everything up.
Oh, you're good. I hope Julie gets back to us.
Oh, you got texted? Oh, sorry.
What'd you say?
Has she not said anything?
Mm-mm.
Huh.
Nope. Which is unlike her.
Yeah.
So.
I gotta fail this test.
What?
Nothing. I'll be right back.
Oh, okay. So I called her and she didn't say anything. So she didn't answer. I don't know if we should just start without her.
Yeah, we can just start.
Or.
Feel it? Yeah.
Okay.
Yeah, let's just start.
Okay. Cool.
Did it read the lesson and everything?
Yeah. I actually already started on the group quiz. Just for
Okay,
fun.
I was going to, but then I was like, I could just work on it later.
Yeah. I'm not as confident in this stuff.
Me neither.
Which is kind of why I wanted to get in there and see what was going on before we started going over it. But oh wait,
I was gonna go to the tutoring center tomorrow, so I can like get some help because I've been struggling a lot with these past lessons.
Yeah, these past like 3. Part of it is me just like not being as focused because of moving, but also I feel like they've gotten a lot more complicated. So
yeah, they're kind of okay.
I figured out. Did you figure out how to open it in Excel and do the?
I have to plug it.
I can tell you how because it's super helpful. It just gives you the answers basically.
So you know how to do it?
Uh-huh.
Oh, well, okay.
Okay. So 1 and 2. I'll go ahead and read number 3.
Mm-hmm.
Is that cool?
Huh?
What requirements must be checked when conducting hypothesis tests comparing two means with independent samples? It's simple random sample, right? And X is normally distributed for each group.
So the first two?
I think so, yeah.
Okay, I was gonna check the book, but if you know it, then we can go with it.
I checked the book.
Okay. The test statistics for hypothesis tests comparing two means with independent samples is the statistics.
Watson, go away.
Okay, I think it's a sample random. It's kidding. Is it T? The T score?
Yep.
Okay.
Okay. Two samples are independent if, and the answer is knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2, because it would be paired samples if they had anything to do with each other. But it's saying independent samples, they don't have anything to do with each other.
Okay, I think that makes sense.
Okay. So, and that's where I stopped because I started doing the Excel stuff. But I figured out how to do it. So I can kind of walk you through it if you want.
Yeah. Okay, that sounds good.
So open that file.
Sorry, the dentist office bills?
Uh-huh.
Okay.
And then go to File and scroll down to Options.
Hold it's not opening.
Okay.
Okay, so File. Oh, dang it.
Hey, my puppy. It's my dog Watson. He's really big.
Hey. Hi. Okay, so I go to File. Options, add-ons. Okay, options, yeah.
Bottom. And then go to Add-ins. It's on the left.
Okay.
And then there's one that says, oh crap, what does it say? Hold on, Watson, go away. Let me make sure.
Loading. Okay, which one is it?
Add-ins, Analysis Tool Pack. And you click on it and then hit Go down at the bottom.
Go.
Mm-hmm.
And it opens something else.
Yeah, then you'll click the little box that says Analysis Tool Pack. And then hit OK.
Okay, got it.
Okay, now you have the software to do all of the hypothesis testing for you. So you go to Draw. Oh, sorry, lies. Go to Data.
It's not working. How do I do it though?
It's on the green part where it says like File, Home, Insert, Draw. Just scroll over to Data.
It's not. It didn't open though.
It doesn't need to. Nothing opens up.
Oh, so I go. Oh, what do I do? So I go to Data, like.
Like the tab.
Oh, okay. Sorry, I'm so confused.
You're good. No, I was really confused too. I just had extra time, so I watched some YouTube videos on how to do it.
Okay.
And then there's a little box that says Data Analysis. Do you see that on the right?
Analysis. Yes.
Yay! That means you got the tool pack because it wouldn't be there if not. So you click on Data Analysis, and then you scroll down.
It says.
Oh, what does it say?
Oh, it opened a little box.
Oh, okay. So
average number. Which one should I click?
That's what I don't know.
I guess it depends on what we're going to do.
Yeah, it depends on the question. And so that's where I got confused because it doesn't say if it's equal or unequal in the text.
Because we're learning right now. Are we doing the two sample means?
That's what I did first.
Is it not that then?
I don't know. Let me read it again.
Two sample. Okay.
Because it talks about the mean in the problem. It says let be the mean.
Do you know how to get the degrees of freedom?
I think so. I think it comes up once you do. I'm gonna do the sample means for funsies.
Okay.
Okay. Let me see. What's the degrees of freedom? Yeah, it should be 18. Try it. Try it on yours. So do the sample means. Two paired sample means. Do you see that? And then you just like highlight one column, highlight the other column.
Okay, so two pair sample means. I think I understand. So is it? Oh, dang it.
Just scroll, like click in the first box, and then go over to your data set and highlight.
Okay, hopefully, and then
it's right. I don't know.
It should. No, what? Do not understand. I'm sorry. Hold up.
You can ask questions. It's okay. I can try to help you.
So I opened the pair two. Oh, what'd I do? Dang it. Okay, so I opened the two sample for means, the little box thing. And I highlighted one side, Idaho Falls Dentist Office, and the other side. But like it doesn't give you a number, sorry.
You don't get a mean difference. You don't put anything in on that box. Right? And then you click the little box that says labels and hit OK.
Oh, labels and OK?
And hit OK.
I think I just messed up. Oh, okay, so I got numbers. Mean is something else, and it gives me like a bunch of other numbers.
Yeah, so I think we just use this chart to fill it out. So DF would be 19, right? Degrees of freedom. Is that what you got on your chart?
Okay, hold up. I need to make it bigger because, okay. So it says that the mean is, there's a bunch of numbers, and there's observation, hypothesis, T-stat, critical something.
What did you get for DF?
DF is DF?
Yeah.
I don't know. Oh, 18. 18. Okay. Is that what it is?
Yeah, that's what I got.
Okay, so that's the answer, right?
Maybe. Unless we're doing the wrong chart. But
okay, what is the sample standard deviation for Rexburg? Standard deviation for Rexburg?
So the variance?
Yeah, so this is the this is kind of confusing.
It should be 40.
Should we get it?
Sorry?
The standard deviation, so should I just hold up?
It should be 42171.55. That doesn't sound good, does it?
Okay, I got not 4.2. Where does it say though? Sorry, this is so confusing.
The variance, I thought the variance would be the same, but maybe I just need to do equal sign SP. Oh, JK, I did it wrong. It's 206.637.
206.637? Yeah, that's what I got.
Oh, okay.
Okay, so it's 206.637. Okay. And then what is a test statistics? Is that on the other chart?
I think so.
Yeah. But which one though?
The one that says P stat, I'm assuming.
Okay, is it then negative 0.290883?
But round to 3 decimals, so negative 0.291, I guess.
Negative 0.291. Okay.
Yeah.
Negative 0.291. Okay, that kind of makes, I don't know. Does it tell us to use this chart though?
So, yeah, it does. I see it now in the textbook. It says click on the tab labeled 2 sample t-test. So okay. I think we're using the right one.
Okay, yeah, I just get super confused. These past chapters have been kind of confusing.
I really hope I'm not wrong, but I mean, if I am, we'll just try
again. Yeah, as long as we're doing it, that's all that matters.
Yeah. Did you do really well on the last test?
I got like an 80.
Yeah. It brought my grade up a lot, so I haven't been like as worried about not doing perfect on this, on the homework and stuff.
Oh, on the test?
Yeah.
On the test.
On the test.
Yeah, no, I didn't do well on that one because I don't think I met with you guys because something came up. And so everything I did by myself and I didn't study well, and then I don't know. I'm not good with numbers.
That's okay.
Yeah.
So now I have to decide the p-value.
I never know how to get the p-value, or like don't know how to. So is it? Do you know which one it is?
I'm reading right now on how to do it. It says P.
Well, one says P2 tail, and the other one says P1 tail.
Yeah, so I just need to look in the textbook to see which one we're supposed to use.
Okay.
It's kind of dumb because in the textbook it says the p-value is reported in cell G23. But we don't have a G23. Statistic p-value on the graph. Oh, since the p-value is greater than the level of significance, we fail to reject.
If it's greater, we fail to reject. If it's less than the A thingy, then we reject it. But we don't know. I don't know how to get the p-value just yet. So
let me try to figure it out really quick. Okay. And they'll tell me once I open it. So. Yeah. One sample. Oh, it says one sample test for means. But why would we have one sample test when we have two? Paired, two sample tests. Oh, I see now. Sorry. I see now. 3. I don't know. I think we need to just pick one and hope it works because I'm not sure.
Oh, okay, hold up. I think I find something. That be 47. Oh, that's so confusing. That's something I struggle a lot with, the p-value.
Oh, I think it's 0.0775. And the reason being, Google says a two-tailed test is a statistical test in which critical area and distribution is two-sided. And maybe because we have two data sets, there'd be two tails on the chart.
So how did you get that though?
Oh, it's on the little chart thing. It says one of them says one-tailed test and then the other says two-tailed test.
Yeah, so is it the one-tailed?
I think it's the two-tailed.
Oh. So is it
I'm not certain though.
What is it? 0.7745?
Or 0.775 with rounding.
Yeah, okay. We can try it. 0.775. And since it's greater than the p-value, then the level of significance we fail to reject. I think it's fail to reject.
Okay. I don't think I did this right, but I don't know what else to do, so. Okay, suppose instead you had to use the alternative. Oh, and that's the other thing. Hold on. The data set gave us a significance of 0.10.
Yeah.
Is that what you were talking about? That's why it's...
Yeah.
Okay.
That's why it's... Since it's greater, we reject the null hypothesis. Fail to reject it, I mean.
Okay. Do you want to do the next one?
Suppose instead that you had used alternative hypothesis. What is the correct decision based on this evidence? So it says that H, or that mean 1 does not equal mean 2. We have sufficient evidence that the mean dentist bills between the two cities are different. We have insufficient evidence that the mean dentist bills between the two cities are different. Evidence that the mean dentist bills between the two cities are the same, and we have insufficient evidence that the mean dentist bills between the two cities are the same. Not the same. Or are they? These always confuse me.
I'm reading to try and figure it out. Okay. I'm going to say we have sufficient evidence the mean dentist bills between the two cities are different. I think that's right.
The first one, right? Yeah, I think so too.
Okay. Now I use the other data set.
Do we do the same thing?
Yeah.
Okie dokie.
Okay. Watson.
Okay, so we go to file.
What's up on your head? I kind of, okay. So just looking at it, and I might be the worst person for guessing this, but I think we're supposed to use the two sample assuming unequal variances. The reason, because if it's paired, then you're comparing, like in the video, it was talking about how if it's paired, the two samples that you're looking at have some sort of relation to each other, but these don't based on the text. You're talking about one group of freshmen in Utah and then another group of freshmen in Colorado, and they don't like know each other. There's no relation there. They just have something in common. And then I would say unequal variances because the variance
yeah, it makes sense because they don't even have the same amount of numbers for the two of them.
Yeah, it doesn't give us like an equal variance. Does that make sense?
So it's assuming an equal variance then?
I think so.
Okay.
I think so. I'm sorry, I don't know.
We can work with it.
Yeah.
I don't really know, so it's better that than nothing.
Stop it. That's baby food. That's not for you. Go on. Bad dog. Okay. I have my little chart.
What?
Talking to my dog. Sorry. Okay. So I think just based on one of the examples I give in the textbook, it's the first one. U1 is greater than U2.
Okay.
The test statistic, what did you get for test statistic?
Sorry, my computer's not working right now. Oh my gosh. For test statistics, 0.48.
Yeah.
9.
Yeah, that's what I got too.
0.489.
Watch me like fail this whole test. I'm so sad. I would say it's two-tailed again for the p-value.
Wait, what's the p-value again?
I think it's 0.632.
Oh, no. What decisions do you make? 0.05. Fail to reject.
Yeah.
It says determine a 95% confidence interval for U1 minus U2, an estimate for the difference between U1 and U2, and put your answers below. Determine the margin of error for the 95% confidence interval. I'm not good at these. Like formula, but like what use?
Yeah, it's the one that we did on lesson 11, right?
Uh-huh.
I don't even have it on my computer, so that would be nice.
Have the formula if you need it.
Oh, I have it here.
Numbers. Okay.
I think. What was the formula you had?
For the margin of error? So it's the score, so 1.9669 because it's 90% times divided by the number.
What?
Hold up. Let me see if there's another one. Isn't it that one? Maybe I'm not doing it right.
1.96 times the standard deviation over the sample size number? Is that right? Okay, yeah, that's the formula I had too. Or square root.
Isn't it 1.90? Oh, never mind. 1.96 here. We get this standard deviation number?
So
both of them?
That's easy though, right? We just do equal xt bev parentheses data set.
Because there's two standard
deviation on Excel.
So, which one do we use?
I think we should use the one that we get on Excel. The 3.4137.543.
I cannot find it.
So go to sheet 1. You see at the bottom little tab things. The sheet 1.
No.
In Excel. Are you in Excel?
Yeah, I'm on Excel.
Down at the bottom of it says sheet 1, 2, 3, and 4. It's like a tab, kind of.
I'm sorry, I don't know.
You don't see it?
Oh. Okay, so what do we do with sheet 1?
So under where it says 14, like in row 14 there, do you see that? It's blank.
Yeah.
Type equal sign STDEV. And put, all right, when you're ready, tell me you're ready for the next step.
19 or 20. Does that make sense?
Sorry?
What numbers did I use? The 13 to 19?
Yeah, you'll, for both data sets, you'll use them for both. So yeah, highlight 13 through 19, and then close the parenthesis and hit enter, and it'll give you the standard deviation.
Okay. And I do the same thing for the other row?
Yeah, tell me what you get though. Make sure we're on the same page.
Okay, so for the first one, I got 4.516. The other one, 3.42.
Woohoo! Yeah.
Okay.
So then, I guess you just, I'm like guessing here, because margin of error, this is a margin of error formula. So I think we're doing it right.
I know, but Well, that's the standard deviation for both of those. But then do we do two different formulas? Like two different equations? One for each?
And then you subtract them, I guess? I don't. Good grief. I wish I knew.
Okay, let's see.
Google it.
So if that's the case, we can do it's 4.517 divided by okay, let me see. Where's my calculator? Mm, 96 times. What did he get?
I haven't yet because I'm looking up margin of error to make sure we're doing it right.
Okay.
What did you get?
I haven't got the other one. I haven't gotten the other one, but for one of them is 0.885. Is that what you got?
That's what I'm gonna go with because I don't think we're doing it right, and so it's like a best guess, but it's kind of shot in the dark.
Divided by 12. Okay, so for one number I got 885 and the other one 0.558.
Okay, that sounds good to me. My dog's.
But then I don't know. Oh, do we subtract them then?
Yeah, I guess.
5 minus 0.559 equals 0.326.
Okay.
Okay.
Okay, I don't know. Sounds better than nothing.
True. Okay, 0.326.
And put the lower bound and the upper bound?
So for that one, you have to just understand what numbers they want me to use. Okay, so for that one, you're gonna use the X bar value. So that should be up here.
The X bar value? Wouldn't that be just the mean that we got when we did the fancy thing?
Yeah, so what's the mean then?
The upper one, I guess, would be 16.363.
Okay, let's just write it down.
Sounds good to me.
What is it?
16.363.
Okay.
And then the next one's 15. The lower bound is 15.444.
15. Wait, what's the upper one again? 16 point what?
16.363. Oh, 16.364.
Okay. Okay, well, pretty sure I got the last ones wrong, but
I think I got them all wrong. I'm gonna submit.
yeah, I can submit it.
We got more of them right than yeah, we didn't do very good. We got a 52.
52?
That's better than 0, I guess.
Wait, I'm gonna see which ones did we get wrong?
Most of them. Okay. So we missed.
Oh, we missed a lot.
Yeah. Question 6, question 8. I'm gonna like study it a little bit more and then retake it later because this is bad.
I don't want to read. Thanks.
Sorry, I did my best.
Oh no, you're fine. Like I don't really understand this. I'm telling you, I need to go to the tutoring center.
Yeah, I feel you there. Well, this was fun.
Okay, do you just want to upload the link then later?
Yeah, I will.
Okay, thanks. I'm gonna cry myself to sleep. Bye.